Hello everyone, in this video I'll be sharing with you on how do I make my own crystal which focuses on the formation of face-centered cubic crystals. My name is Aina Farisha binti Khairul Amin. My matrix number is 22003547. The first part shows the information about what is crystallization. It is a process that occurs when molecules or ions come together in a well-defined rigid crystal lattice. The lattice structure forms due to changes in temperature or the concentration of a salt solution. The smallest entity of crystal lattice is called a unit cell. A unit cell can accept atoms or molecules, allowing crystal to grow into a macroscopic structure. The first step involves stirring the impure solid in a suitable solvent. A solvent is chosen based on the ability to dissolve the substance when heated. As you can see on the first diagram, stirring the water is to dissolve the solid completely to form a solution. Next, the solution is transferred to an evaporation basin and heated using a flame. The heating process causes most of the solvent to evaporate, leaving behind a concentrated solution. The diagram shows when the solution is cooling, the solid solubility decreases. This allows crystals begin to form. Lastly, the crystals are collected by pressing them between sheets of filter paper to remove any excess solvent. Therefore, this crystallization process is a method used to obtain pure crystals from impure solid. The materials and equipment used in this process is 40 grams of stable salt, 100 ml of water, spoon and plastic strainer. The process of making crystal begins by preparing a saturated salt solution. First, pour the 100 ml of water into the pot and boil the water. After that, pour the table salt weight 40 grams into the pot. By using a spoon, stir the solution continuously until no more salt dissolves. The solution is heated until the salt is evaporated and small chunks of salt float to the surface. Allow the solution to cool and undisturbed for 24 hours. After a day, filter the solution using plastic strainer and pour into a flat dish. The dish is placed in a cool, dark and undisturbed location for 1 to 2 days. The solution was transferred into another flat dish and this is the result. Take out the crystal using a tweezer and place it into the center of flat container. Grow the salt by pouring the salt solution and leave it evaporating. After a few days, the crystal looks like this and this is the close-up version. Next, this is the information on how sodium chloride crystals are formed. The process involves 4 steps, which is dissociation in water, evaporation, ionic bonding and crystallization. First, dissociation in water means that when sodium chloride is added into the water, it separates into 2 parts, which is sodium ion and chloride ion. These ions are surrounded by water molecules which prevent them from bonding immediately. Next, as water evaporates, the solution becomes more concentrated. The ions have a higher chance of interacting with each other. The third theory of sodium chloride crystal is the ionic bonds that is very strong, formed by Na plus and Cl minus that is attracted to each other because of their opposite charges. Ions start to arrange themselves into a repeating structure. Lastly, the sodium and chloride ion arrange themselves into a repeating cube-like pattern called crystal lattice. The NaCl crystal structure is known as a face-centered cubic arrangement. In this structure, each sodium ion is surrounded by 6 chloride ions, and each chloride ion is surrounded by 6 sodium ions. This alternating pattern of positive and negative ions creates a stable and strong crystal lattice, giving NaCl its cube-like shape. The coordination number of sodium chloride is 6, which means that each ion has 6 nearest neighbors of the opposite charge. Specifically, every sodium ion is surrounded by 6 chloride ions and every chloride ion is surrounded by 6 sodium ions. These arrangements helps minimize repulsion between ions of the same charge and ensures the stability of the crystal. Next, one of the important characteristics of the FCC structure is its symmetry and packing efficiency. In this arrangement, the ions are packed closely together in a way that maximizes space utilization while minimizing empty gaps. Sodium ions and chloride ions alternate positions at the corner of the cube and the centers of the cube faces. This close packing creates a strong and stable crystal. The sodium chloride crystal also follows a repeating pattern in its structure. The chloride ions are positioned at coordinates 0, 0, 0, while the sodium ions are offset at 1/2, 1/2, 1/2. This creates an alternating pattern of positive and negative ions that ensures the structure remains electrically neutral and highly symmetrical. That's all from me. Thank you for watching.